Now let's take a look at some formatting options that are available with C++. In this program, we have the same header as always. Then inside the main program, I just have one variable called pi, and it's set to a type double. And one thing I want to point out is that I have 8 digits to the right of the decimal, so that'll come into play soon. The rest of this program, it's mostly comments, so we will fill in these comments as we go along. First of all, we write some information out to the screen, so this just writes out the string constant output options, and there are 2 end lines, which means that it will skip a line and then go to a new line. So essentially there's one line between this cout statement or the printout on the screen and then this one. So the first one says that we want to output pi in scientific format, and that brings us to the first of these things that are called manipulators. The manipulators have to have this pound include the input-output manip so that we can use all of these various manipulators. So the prototypes for them is they will be defined up here. Okay, let's follow the comments. So the first thing we want to do is to set the scientific manipulator. These are all connected to cout. So if you want to set them, you use cout, and then we use the insertion operator for output, and this is just scientific and semicolon. Okay, now this is a manipulator. Okay, so your first manipulator is going to be called scientific, and what that will do is just to set your output format to scientific notation. Okay, so that's what this does. Now, if we want to write out the variable pi, then we just do a cout, which I cannot type. There we go, cout insertion operator, the variable pi, and an end line. Okay, now I want to work through this step by step, so I will use my system pause, which I could use on Windows. Okay, remember again, this only works on Windows. And we can see what that output looks like. So let's build the program, and then we'll run it, and we'll see what the scientific manipulator gives us. So I'm going to build the program, and then I'm going to run the program. So let's bring this window over. So there you see it. So we have the output option shows up, and there's that blank line I was talking about. So the end line to end line, the first end line sends the cursor here, the second end line sends it down there. So we end up with a blank line in between. So then we print out pi in scientific format, and then we use our scientific manipulator, and then we just print out pi. And you can see it's in scientific notation because you have the E plus and then whatever exponent you have over here. So that's scientific form. So that's what that does. It says that your output will be in scientific notation if you turn on this scientific manipulator. Okay, so let's stop the program. And I want to go back and let's add another variable here. Okay, let's do double, and let's put in, like, see, double big number, and let's say 34876.237892. Just making up stuff here. Okay, 892. And let's also print out big number, and let's see what happens there. Okay, so we'll print out pi, and we'll do cout big number, and also an end line, and then the system pause stays where it is. Okay, so now let's see what we get in that example. So I'll build it again. And it works. So then I'll run the program. And let's look at the output that we get. So here's pi in scientific notation. Here is big number. Now notice that we have e plus 0.4 this time. And in both cases, there's one number to the left of the decimal. So this scientific format will always output numbers in this form. So you'll have one digit over on the left, and then a dot, and then if we don't specify it differently, there will be 6 digits. That's important to remember. I haven't shown you the manipulator yet to let you change that. So the default is what we call our precision here, so it's 6 digits of precision, followed by the exponent, followed by whatever power. So a big number is 3.487624 times e to the fourth, which is times 10 to the fourth. All right, so that's the scientific form. And once you turn that on, then the scientific flag is set until you change it to something else. Okay, so let's stop the program. And let's move down. Okay, the next thing says set fixed. So fixed will be our second manipulator. I want to drag down the system pause so that we can see the results of both of those things, and then we'll stop. The way that you set fixed is the same way that we set scientific. So cout fixed. Okay, well, what does this do? This just gives you what I'll call the regular real number form. That is, it will not have an exponent as part of it. Say regular real number. Okay, so it will have a whole part and it'll have a fractional part. And the best way to show you what that looks like is to actually print it out. So let's do cout with pi now with an end line. And let's also print out the big number. So I'll just copy and paste that line. And then the system pause will stop right there. So if you have the output formatted as fixed, then you will not have the scientific notation. So let's build the program. Let's run the program. When it's ready, it's ready. So here is the output and what we call the fixed notation. So let me line that up. So these two, that's the scientific notation, and here are the same two numbers with a fixed format. So you can see that the period, especially in big number, the period stays where it was. It doesn't float over here next to the 3. And we also still get 6 digits for each one of these. So pi has 6 digits to the right of the decimal, and so does big number. But in this case, we don't have the exponential form showing up. So there is fixed. So you just choose which one you would like. If you're not using applications that are in the sciences or engineering, then more than likely, you're just going to want to use fixed. It's important to note that whenever you select one of these, it remains in effect until you change it to something else. So the scientific manipulator was set here, but now it is turned off and replaced by fixed here. Now, moving down, let's see how we can format these numbers by specifying the number of print positions on the screen, which is field width, and the precision. All right, so I'm going to, once again, I'm going to take the system pause and I'm going to move it down here. Now, this says cout, pi in fixed format with width and precision set. Okay, 4 digits to the right of the decimal. Now, how do you do that? All right, if you want to control the number of digits to the right of the decimal, then there's a manipulator for that. And that manipulator is called setprecision. C out. These all are connected to the C out statement, set precision. Then in parentheses, you indicate how many digits to the right of the decimal that you want. Okay, so that's 4 digits right of decimal. That's what this does. So if you were using the older C notation, then you had a percent 6.2, for example, or a percent 12.8. Then here would be the number that follows the point in the old notation with your printf. But since we're moving on to the more modern C out statement, then all you have to do here is set precision once, and that remains in effect for every output of a float or a double until you change it to something else. All right, so now let's print out our two numbers again. So I'm just going to go get pi and big number. I'll copy that and I will paste it here. So we'll print out pi and we'll print out big number after setting the precision to 4. Okay, so let's build our program and run it. All right, so here's the output. Now, let's line this up as well. Okay, so we have pi in fixed format, 4 digits right of the decimal. So let's move that down. So now you can see the output here, C out pi end line. Notice the precision is 4 digits to the right of the decimal. And in the case of big number, then it's also 4 digits to the right of the decimal. So as a programmer, you can control that. And remember that once you set it, it stays set until you change the precision to something else. Let's scroll up and look at those numbers. So in this case, pi, we had 8 digits to begin with, and a big number, we had all those. So the output is going to be rounded. Let me scoot that up. It's going to be rounded up. So in this case, we get 1416. And in the case of big number, it's 2379. So that last digit will be rounded up. So that is an example of set precision. Let's move on and let's look at how we can set the output field. Now, the output field is just how many print positions that we use on screen to output some value. We'll keep moving the system pause down as we do these things. So we want now to set a 10 space output field. The way you do that is C out once again, and the manipulator is called setw, and in parentheses we put the number of print positions that we want. So now whatever number that we output following this, it will be output in a field width of 10 print positions. The precision is still 4. We haven't changed it. So now this will in effect be the same thing as a percent 10.4 if you remember or have used printf. All right. Now let's just copy and paste our two numbers. And we'll print out pi, we'll print out big number. And notice carefully what we get when this happens. So I'm going to build the program again. And I'll run the program. And here is our output. All right, so we have, let's line this up so we can see exactly what we're generating here. Okay, now we did set the width to 10 and then we output pi. So here's the output from that line, that output statement. So let's count the number of positions. See, notice there's some space. There's some space over here to the left. Okay, so if we look at the numbers up above, we can tell there are 4 spaces right there. So counting from here, that's 1, 2, 3, 4, 5, that's 5, 6, and then space, 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 space. So that adds up to 10 spaces. The number's right justified, and it has a precision of 4. In the case of big number, the number of spaces was exactly, we needed all 10 of those spaces to print the number, so there is no space over here on the left. But once again, that entire field takes 10 spaces. Now, I want to change this up just a little bit, so I'm going to stop the program, and let's modify that just a little bit here. We're going to do set width to 10, and we will output pi. And I also want to output big number here, then the end line. So that means that these two values will both be output on the same line. And let's also make this big. Okay, let's make this, since we have big number is a big number, let's make that 12. So the precision is 4, and the number of print positions this time will be 12. So let's build the program. Let's run the program. And now, let me also line this up so we can see the output here. So here we have the two numbers, and look carefully. Here is pi up to that point right there. Right? So I made the width 12, so there's 1, 2, 3, 4, 5, 6, and then there's 7, 8, 9, 10, 11, 12. So pi really is output in an output field of 12 with a precision of 4. But big number is immediately afterwards. It's all jammed up against it. And if we count the spaces, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there are 10 spaces, but if you look back over here, we did set width to 12. So what's going on? This is one of the special exceptions that we have to take into account for the setw. Every manipulator, scientific, fixed, precision, those all remain set until you change them. The thing about set width is that it has to be used for every output. So set width 12 only applies to the output for pi. It doesn't apply to big number. Bummer, right? So if we want big number to be output in a field width of 12, then we have to restate the set width. So I'll put the end line back here. Well, actually, I don't want to do that. I don't want to do that. Let me back up. Because we can put the set width here. We can put it in the same line, set width 12, and then another insertion operator, and then big number. So it's okay. You can mix these manipulators in with the actual variables that you want to print all in one cout statement. That is perfectly legal. Now, let's try this again. So we'll build a program. I need to stop it first. We'll build the program and then run the program. And let's see what we get this time. Oh, well, for some reason the format is much smaller, so let me fix that. Let's make that bigger. Let's go 20. That's too small still. Let's make it bigger. There. Okay. So now you can see the output. So let's look at this line, the last output again. So we output pi, and we have a width of 12. Okay, so there's 1, 2, 3, 4, 5, 6, and then we have the 6 spaces over here. This time, we have used set width a second time right before big number, so now we have 12 print positions here from the 9, that's 10 of them, and then here's 11 and 12. All right, so now we have big number is also right justified in a field width of 10. So it's very important to remember that set width must be used prior to anything that you want to output. To say it another way, once you do a set width, it applies only to the next output, and then it's done. Afterwards, set width is no longer in effect. So if you want to format the next output, you have to use another set width here. Okay, now moving on, let's drag our system pause down. We're almost done with this example. This says that we want a width of 6 with 2 digits to the right of the decimal. Right, so let's just use pi in this case. But a width of 6 and a precision of 2 is what we want. So we can write it like this: cout, okay, set width to 6, and we can use the insertion operator and set precision to 2, and then we can output pi, followed by an end line. So you can combine all these things on one line of your cout statement. You don't have to have a separate cout statement just to handle the manipulator. So in this case, we have a width of 6. There's that. We want a 2 digits of precision. There's that. Then let's just output pi. So I'll copy my cout. Let's output pi. And let's give this one a try. Oops. Don't want that. Build. And run. The output looks like this. All right, so let's look at the bottom one, the last one that we did. Well, you know what? I actually doubled up on this when I shouldn't have. Okay, this line here, okay, that one prints out pi once, and then I print out pi again. So I should have not have done that line. But that's okay. Let's just look at it. You can see that the output on that line, we have a precision of 2. And if you count the width of the field, how many print positions we have 1, 2, 3, 4 here. Okay, and then 2 there. So that's a field width of 6, and that's a precision of 2. On this last line, then the precision is still the same, but there's no set width. So in that instance, it just prints out pi, and it only takes up the amount of space that it needs to print it, but it still has a precision of 2. All right, now let's move on to the next example. So now I can just eliminate this system pause here because the final one is at the bottom of the program. And let's take a look at this. This one says a width of 6 with 6 digits of precision. Now that tells me that seems weird. How's that going to work? If I want to print out pi and I want to print out with 6 digits and a field width of 6, then the number isn't going to fit. But let's give it a try. Okay, so let's first of all, I want to take out that extra cout statement for pi up there. Now let's do cout precision of 6. Okay, so precision of 6, and then set width also to 6, and then print out pi with an end line. Now, what do you think will happen here? Well, nothing. That would be an error because I can't type it correctly. Now what do you think will happen? Well, I'm asking for something that doesn't make sense. Let's see what the computer does. Right, let's build it. And run it one more time. Okay, let's bring our output over here. So this very last line corresponds to that last cout statement. So here's what we get. Okay, precision is 6. That's correct. Okay, so you can see the precision, 1, 2, 3, 4, 5, 6. But clearly, when we did the set width of 6, it ignored it, which is nice. Okay, so here's 6 digits of precision, but it takes 8 print positions. So the last thing from this lesson that you need to remember is that if you have a width that you specify that happens to be too small, then the system will override that and it will take as many positions on the screen as it needs in order to output the results. All right, so there's your introduction to several of the manipulators that you can use to format your output. Once again, quickly, we have scientific to give you scientific notation. Fixed will give you real numbers. And remember, it doesn't make sense to have a fraction for an integer or a character. These only affect floats and doubles. So fixed and scientific will give you those formats. The precision gives you digits to the right, and the set width will allow you to choose how many print positions on the screen that you want to use in order to output your data, and it will be right justified in that number of print positions. Okay, well that's enough for this video, so let's close it out and we'll continue with some other manipulators in upcoming videos.